All right. So today's session is going to be quite short, and we just want to talk about some backups, recovery, and talk about some best practices when it comes to both of these things. And so this week I already done some recordings already that will now follow on from here. So I'll send those out to you during this week so that you can progress with that also. So in SQL Server, there are three major types of backups, really. There are three of them. All these other ones are extra. So, but they're also important to talk about them. So that's why I decided to list them out. So the full backup is the complete backup. It's like taking the entire data in your database and backing it up. So it's full, it's complete. There's nothing more we want to explain about that. And differential is just the changes that has occurred after you've taken the full backup. So if you want to implement a disaster recovery strategy, you have to consider all these things to be able to know the best approach depending on a number of things, which we'll talk about soon. The third one, which is the transaction log backup, is the changes that has also occurred in the database after your differential backup. So depending, you can have a mix of full and transaction log backup or a mix of all three. So if you want to have a mixture of all these three as part of your disaster recovery strategy, so what's going to happen is you take the full backup first, you take the differential backup, which will only store changes that has occurred after the full backup, and then you take the transaction log backup, which is nothing but the changes that has occurred after the differential backup. But if you want to remove differential out of the mix, transaction log is typically just going to be changes that has occurred after the full backup. And there are implications to each of these files because this has the extension which is .back, and this has its own extension. I think it's DIFF or something, I don't know, I can't remember, but I can check for that. And this has a .trn extension, but we're going to practice all these things with time. I'll send it recordings for all the practice around this ones. So we now have another kind of backup, which is the tail log backup, and this is not a regular backup that you would take just because it's not a backup that you can take and consider as part of your disaster recovery strategy per se. Okay, but you can also include it. So what it means is, after you're taking your transaction log backup, if certain changes occur after this transaction log, it will be appended to the end of the log, and that's why they call it the tail log backup. So if you have restored, so let's say for example you have a full backup that you took at 11, and that's 1100, and then you have a differential backup you took at, let's say, 1145, and you have a transaction log you took at let's say 1200, and then you have a disaster that struck at, let's say, the last transaction log was at 1200, right? So a disaster now struck at, let's say, 1205. Now you don't have another transaction log backup between 12 and 1205, but then you can have a backup, which is the tail of the log backup, which can store the data that has happened between this time, so that when you're restoring all the backups, you can also apply the tail of the log backup as well, and you effectively have no data loss at all. We're going to simulate all of these things and we'll see how they work in due course. So we also have the file backup, we have the file group, partial, partial full, partial differential, copy only. So the file backup is just taking a backup of your database file. So remember we talked about the MDF file, which is similar to the .dbf, which we have in Oracle. So it's like saying if you have 5 of these files, yeah, so if each of them is about, let's say one of them is 1 terabyte, the other one is okay, let's say we have 2. Let's simplify it. So one of them is 1 terabyte, the other one is just maybe 50 gig. You don't want to, you know, be backing up everything, because for example the 1 terabyte one might actually be a read-only database file. So you can actually be backing up the 50 gig file because that's the one that has read and write going on there. So file backup is doing a complete, it's like doing a full backup, okay, of a file, if that makes sense. So you're not doing a full backup of all the files, you're only doing a full backup of just one file. So you can back up each of the files individually. Because if you run a backup or on a full backup, if your backup was full, what you're effectively doing is backing up all the files. So if you had 10 different files, you're backing up all the files. But with a file backup, you're only backing up one. Now we have the file group backup as well. So you can have multiple files inside a file group. So it's like saying you have different MDF files inside a table space. So it's like doing a table space backup in Oracle, but in SQL Server we call it file group. So you can have multiple files inside a file group and you can do a file group backup. So if you have multiple file groups, depending on their sizes, you can, you know, come up with a strategy to only back up the file groups and not back up certain file groups for certain reasons. And partial backup, I wouldn't say it's a type of backup per se. I won't say it's a type of backup, but it's a concept also. So it's like saying you are backing up the active part of a database, okay? Because there is in SQL Server you can't right click and say okay, backup partial back, you understand? So what you're saying is if we have 2 file groups, for example, and you are backing up only one because the other one is read-only, then you're doing partial backup. So when you back up only a part of the database, you're doing a partial backup. So that's why I said it's not like a type of backup per se, but it's a concept that you just have to be aware of when they talk about partial backup. That's what they mean. And with partial backup, it allows for a concept called piecemeal recovery. So what piecemeal recovery means is, you know, when it's time to actually recover a database, you can actually do piecemeal recovery by restoring the active ones first, so that at least your database can become accessible in a minimal time period, okay? And then the big one, which is not active, which is most likely going to be a read-only, probably because it's an archive file, you can then begin to restore that one later on. But at least if that one would take 24 hours to restore, the one that took 30 minutes to restore because it's smaller would have been made available to the database, you know, first, and then the other ones can start coming up afterwards. So there's the partial full. So you can implement this partial strategy on the full backup. You can also implement this partial strategy on differential. So that's what it means there. So if you say partial full, you're doing partial backup on the full and differential, but you can't do partial on the transaction log. So the last one is the copy only. So what this copy only means is when you have a disaster recovery strategy, and that strategy is to back up full database maybe once a week, and you back up differential once a day, and then you back up transaction log, let's say 15 minutes every day. Now when these operations happen, there is a chain such that when it's time to recover, you need to get all the files that are related to this chain before you can actually complete a recovery. If any of the files are missing, you won't be able to recover. Okay, so this is where copy only now comes in. So if you need to take a backup that is outside this strategy, that is outside this chain, okay, if you need to take such backup, you specify this option to say copy only. So you're only doing a copy only backup. It's going to be a full backup or differential or transaction log, whichever it is, but it's not going to be a part of your maintenance plan. So the reason is this: it's possible for you to take a backup, for an ad hoc reason. Let's say a department in the company says, okay, can we have our dev environment or UAT environment refreshed? And you take a backup of the production server and you restore it on the UAT. If you did that and you didn't specify this copy only, if let's say 2 days after your space is becoming filled up and you're looking for what to delete, remember you took this backup just to refresh the environment one-off, and then you may be tempted to delete the file because you refreshed the environment, you've done what you have to do, and you feel this file is no longer needed. You've forgotten that because you didn't specify copy only, it's been made as part of this chain, because the metadata that's been recorded by the database is going to record the sequence number for that backup and include it as part of the chain. So if disaster strikes the next day and you now want to restore, you won't be able to do a recovery because one of the files are missing. So to eliminate that possibility, that's why Microsoft introduced this concept called copy only, so that if you want to do all those kind of ad hoc backup, you can just specify this option and then you can have your backup going on and the maintenance plan is not going to be affected at all. So these are the types of backups we have in SQL Server, and that will lead us into this, which is the deciding factor. So how do you decide which backup to use at any point in time and all of that? It depends on the size of the database. So if your database is less than 100 gig, you probably don't want to have a complex maintenance strategy. Just a full and transaction log is just enough, okay? But then you can also consider full only, depending on these two concepts, which is the RPO and RTO. So if the RPO, which means recovery point objective, and it typically means how much of data can we afford to lose. Now, if the recovery point objective is 15 minutes, meaning if we have a disaster right now, what amount of data can we afford to lose such that when we are back into production, we are happy, not happy, but we can afford, just afford to say, okay, we've lost 15 minutes worth of data. Now, if that is the business requirement, then you now want to develop a strategy that has to do with, let's say, a strategy that has to do with something like this. Let me explain. So you can have a full backup that happens, let's say once a week. Okay, so this will be on Sunday, for example, and then you can have differential backup happening once a day. Okay, you can have this going on every day, and then you can have transaction log happening every 15 minutes. So what that means is, if the last transaction log backup happened at 12 o'clock and disaster happened at 12:14, the next transaction log should have been 12:15, right? But disaster happened at 12:14, such that we were unable to take the backup that would happen at 12:15. If it's time to restore, the last transaction log backup that we can restore is 12 minutes. It's 12 o'clock. So that means we've lost 14 minutes of data. Except, of course, if you are able to do a tail log backup, you can have additional 5 minutes, and you still lose. If you remove 5 from 14, you can still have let's say 1209. You're still going to lose some data anyway. So if this happens, then you have fulfilled this requirement. So within 15 minutes, we're still able to recover to a point whereby we've only lost 9 minutes of data. So that's cool. But if you're, usually when you find yourself in a situation or in discussions in companies, and you're gathering requirements, and you ask them, oh, what's the RPO and RTO? We'll get into RTO soon. What's the RPO? What they'll tell you is, oh, no, we don't want to lose no data. No, the RTO is how long of downtime can we afford? Like, if disaster strikes now, how long do we have to perform the recovery to come back online? So they can say, oh no, we can't afford no data loss at all, and we don't have the time to say we want to recover. Can't you have a solution that will immediately bring the environment up and running again whenever there's disaster? Of course, we can have a high availability solution such that if disaster strikes on one data center, we can have the other data center servicing the request. But what if the disaster strikes on both data centers at the same time? It's rare, yes, but let's just assume it happens. There's still going to be downtime. So you now have to be able to convince the business and say, look, it is just not realistic to say, no, we can have no downtime. No, we can have no data loss. We should still be able to define these two things. And, as far as I've seen from my experience, is usually 15 minutes of RPO and 2 to 4 hours of RTO in typical environments. But some environments will tell you no, they don't want nothing, but you still have to be able to argue it and discuss it with them that we have to be realistic. These are what are obtainable. So these are the deciding factors that will not lead you to design a strategy for the kind of backup that you want to take. So if, say for example, the RPO says, oh, we can actually afford 24 hours, maybe the data doesn't change during the day, maybe it's only at night that the data changes, okay, and they can say, okay, we can actually afford to lose not to lose, actually I'll leave this one here. Let's say we can actually afford 24 hours of downtime. Okay, so 24 hours of downtime, then you can now design a strategy and say, okay, fine. If that's the case, then we can do a backup and probably forget about doing, differential, and just do full backup that happens maybe once a day. That kind of thing. You understand? Once every day. And let's say this one is now, maybe 12 hours of data we can lose. You can just forget about every other one and just do full backup. But the whole idea is just for you to understand that deciding the strategy whether to use full, differential, or transaction log depends on all these things. The size of your database can be a deciding factor. The RPO and the RTO can also be deciding factors. Now that leads us to recovery models. So there are three major types of recovery models that we have in SQL Server. So the first one is simple recovery, and the simple recovery model is just to say that whenever transactions happen in database, they are not they are logged because we still have our MDF file, and we also still have our LDF file. And we know that the MDF file is the main data file. The LDF file, which is the transaction log data file. So when changes happen in the database, we have them going into the LDF file. But what happens is whenever there is a backup, okay, in simple recovery model, the space within this file gets truncated. So if the file is, let's say, 50 gig, okay, I'm talking about the LDF file now. So if LDF file is 50 gig and you now do a transaction log backup. Within that transaction log backup, there are data pages that we talked about before. These data pages get flushed into the MDF file, and what happens is all the data pages are being, the space that's been taken up by those pages are being flushed out. So if before the backup happened, out of this 50 gig you had 49 gig, okay? If the backup happens, it flushes the whole 49 gig to the MDF file, and the space is being taken away. So it doesn't keep the space in the transaction log file. That's what it means. But the full recovery model, on the other hand, when a backup happens, it still retains the space. Okay, so you have to, think logically what you can do with this. Now, with a simple recovery model, you can do a full backup. Okay, you can only do a full backup with a full recovery model. You can't do a transaction log backup. Okay, so with full recovery model, that you can do transaction log backup, then you can design a recovery strategy that can allow a 15 minutes of RPO. But if you use a simple recovery model, it does not use transaction log backup. So what that means is you can't be doing 15 minutes of backup all the time, and you can only do a full backup. So with that, if you do a full backup, which happens, let's say, once every day, okay, once every day, if disaster strikes during the day, you can lose all the data that has ever happened. So if your database is going to be read only during the day and changes occur at night, you can decide to only use the simple recovery model. And using this simple recovery model, you understand that the transaction log files, it doesn't keep the space. But with full backup, you can use the transaction log, which can allow you to recover to, a point in time, like last 15 minutes. Okay. And you can understand also that the pages inside the transaction log backup, they get logged every time there's a transaction. It gets logged inside the transaction log file, and when you do a backup like that, it gets truncated, but it still retains the 50 gig. And the bulk log recovery model works exactly like the full backup. Okay, but the only thing is, whenever you do a bulk operation, it doesn't log all that information. So let's say you issue this kind of command and say bulk insert, and with bulk insert, you are inserting bulk data into a table. The transaction that occurs for this operation does not get logged inside this LDF. So this recovery model is good for operations that require a lot of bulk data operation. So it does not blow up your transaction log by logging every single bulk operation that happens. So the reason why I said it works as a full backup is because the transaction still gets logged as normal, except for bulk operations. All right, so that's the only difference between bulk logged and full. But simple is completely different, because you don't use the transaction log with simple, and the transaction log works differently with full and bulk logged. And then that takes us to recovery options when it's time to actually perform our recovery. So this one, I believe you understand it much better when we start practicing things, when you start seeing things in real life being happen hands-on. So we have the no recovery, there's the recovery, and the standby. So this no recovery is when you start restoring. So let's say, for example, you have one full backup file, So we have one full backup, and here we have one differential backup. And let's say after this differential backup, you've had different 15-minute transaction log backup, and now you have, let's say, 25 of them. For example, you have 25 transaction log files. Now, when you start recovering, when you issue the first restore, you have to put no recovery. The reason is because you're only saying no recovery just to tell SQL Server that I have some more files I'm bringing in. So do not recover the database yet. Okay, so just restore this, because there's a difference between restore and recovery. So restore is you're restoring the file, but you're not bringing the database to a point of consistency. So you're restoring it, but I'm still bringing some more files. So you specify no recovery. For the differential backup as well, you specify no recovery. For all the 24 files, you specify no recovery. But for the last one, you now specify recovery. So the 25th file will now have recovery appended to the statement. And by then, you can now say, I have a recovered database that is now consistent. The third one is standby. And we use this to configure things like mirroring, whereby you want the secondary server to be in read-only mode. So this is an option that you use to restore the database, so that SQL Server understands that it's just going to be on standby and available for read-only operations. So these are the basic things that you just need to understand as far as backups and restore is concerned. So the next one is just some things I highlighted. They are more of best practices. So they are guides to help you to make decisions as well. So if you have a database that is 100 gigabytes or more, then you can say you want to start splitting the files into file groups, because that will help you to manage the recovery and the backup as well. So let's say, for example, fine, I said 100 gigabytes or more, but let's say this is actually 1 terabyte. So if this is 1 terabyte, you can split them into file groups, and when it's time to backup, you won't have to do a full backup of 1 terabyte that may take you 24 hours. You can actually back up the file groups, which will take you, few hours to do. And when it's time to restore, you can also start restoring it gradually. It's pretty much what we talked about before, but this is like a guide to say, okay, once I find out that my database is 100 gig and more, from 200, 300, 400, 500 gig, 1 terabyte, you want to start implementing these strategies, or you want to start discussing with the business that we should, plan some time to do this. Another strategy is partitioning. So partitioning is also something that we're going to look at. So we will see how partitioning is being implemented. And partitioning is basically taking a whole table. You can have a database that is 1 terabyte, and it's just maybe 1 or 2 tables on that database, that actually occupies all the data, all the size. So there are some environments like that they have a table that just archives a lot of data, and because of the retention policy, maybe they have to keep 10 years worth of data, so they are unable to delete it. So such tables, you want to start partitioning them, and when you do partition them, you can put part of the partition into specific file groups. So what happens again, takes us back to the concept of file groups, whereby if you have to back it up, then you only have to deal with the file groups only, rather than the entire database. So you can also consider partial restores as well. So we also talked about that, but it's also saying if you have more than 100 gig database, you should consider all these partial restores that we talked about, before. So now these are also bullet points I put together as a result of best practices. So recovering your database from disaster, you want to always test your backups can restore. So always test your backups can restore, because it's possible for you to have backup files, but those files may actually have page corruption, which you may not detect when you are backing up the database, or your instance may not even report that corruption to you if nobody is accessing that table, okay, or page. So you want to be able to test your restores and run a consistency check. There's a command for that, which is dbcc check db. So when you do your restore, you can restore on a test server and run this check to check all the pages in that database to check for consistency if there are corruption or anything like that. So as a best practice, you want to be able to do this at least once a month. Take your backups, no matter how big. Practice your restore by taking your file groups or files, as the case may be, and do all these things. Practice them, because when disaster strike, you may be under pressure, but if you are used to practicing these things, you know exactly what to do, where to go to. You won't have any trouble doing this at all. So have a disaster recovery plan already mapped out, so that you're fully prepared. Then always test your plan frequently. I just spoke about that. So always know your facts. So you want to know, how long does my backup take? How long does my restore take? Because sometimes you might find yourself in meetings where you have to give the business this information that they may use to make decisions. It might be in terms of migration projects you want to do, or anything like that, or even in terms of disaster recovery, because disaster recovery for database is just part of an entire IT department recovery plan, if that makes sense. So if a data center goes down, that data center is going to affect a lot of things, not just the database. So your group IT manager may be interested to know the overall possible time it will take the entire IT department to be back into action. So you want to be able to give them information about how long it takes to back up, how long it takes to restore, and you can only know that after you have practiced all these things using the live production data. So take your production data from time to time, put it on UAT, test your backup, test your restores, and all that. So know the database that stores your backup information. So when you install SQL Server, you would see there's a default database that comes with it, which is the MSDB. I don't know what that MSDB actually means, but let's say it's Microsoft database. That's the database that stores your information about backups, agent jobs, email alerts, and all of those things. So this is a critical database for your backup, because you can use its metadata to script out things, to do a whole lot of things. There are certain scripts that I'll also share with you for a lot of all these activities. Then have a dynamic restore script handy. So I have one. I can share this with you, so that you can have that handy. So when it's time to restore, all you need to do is just run that, and it will dynamically pick up the last differential, the last transaction log for you, and then script it out for you. That all you need to do is just copy it, paste it in your query executor, and just run it. Given that the files are at the location which MSDB is aware of, it will be able to just restore the database for you, and within a matter of minutes or hours, depending on the size of the database, you would have your service back into action. So that's the end of today's session. I just wanted to bring this knowledge up so that we are up to date, so that when we start doing other things, we can we already know this concept, so it won't be shocking that we're talking about them during those videos. So do you have any question at all? Thank you. Okay. Mm-hmm. Marry them together. Yeah. Mm. Okay. All right. Cool. 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 So during the week, I'll send you some of the recordings that are already done, so that you can start setting up, installing your SQL Server on the environment. Because my strategy is, we've done the infrastructure implementation already, which is the domain control and all that. So we'll be doing different things. So let's say we want to do always on, for example. So we'll take part of the servers, implement always on. We'll also take part of, if we need to spring up another new server, we'll spring up a new server, implement other solutions, so that everything can be done inside that domain, because that's how you'll be working when you get to work. You'll be using your domain to work. So it makes sense, because I can as well say, okay, install these things on your computer without building a domain, but certain things will be missing. So for example, we want to configure linked server. With linked servers, you can obviously do that without being as part of a domain. But because you will be working in a domain, we may find a way around it to make it work outside a domain. But I don't want you to do that, because you are going to be working within a domain. So there's no point practicing something outside the domain. You understand? So like, I've done some installation videos already, so I'll send that to you, and then the post installation as well, I'll send that to you. We can work on that, and then we'll be, there's no pressure anymore. You've gotten a job, so there's no pressure trying to make it